I would like to add some information to the previous problem that we just solved, because not only have we solved for vector x, so for all the variables x1, x2, x3, and x4 by doing Gaussian elimination, but in the process we have also found a lot of information about matrix A, which is this matrix here, which formed the coefficients. Yeah. So what information have we found? So remember, the rank of the matrix A is equal to the number of columns that have a pivot. So here we have 2 columns that have a pivot. Therefore, the rank of A is 2. The nullity of A is equal to the number of columns that do not have a pivot, which in this case is this one and this one. So therefore, the nullity of A is 2. Yes, and we can check the theorem of dimensions that n equals rank plus nullity, where n is the number of dimensions of the input space. And remember, here we had 4 unknowns, 4 variables, which means that our input space is 4-dimensional. Also notice that the nullity of A is 2. This means that the null space has 2 degrees of freedom. So the null space is a 2-dimensional plane. So okay, this plane is living in 4-dimensional space, but it's still a 2-dimensional plane. And indeed, Gaussian elimination gave us the null space, and the null space is a plane. It has 2 degrees of freedom. And of course, the nullity is equal to the number of columns without a pivot, because those columns are free variables, which we turn them. So the free variables, which are the columns without a pivot, those are x2 and x4. We turn those variables into parameters, alpha and beta, and those are the parameters that appear in the null space. So of course, the number of columns without a pivot form the free parameters, the degrees of freedom of the solution, and that's equal to the dimensions of the null space. So that's why the nullity is equal to the columns without a pivot. Also note that since rank is smaller than n, or nullity is bigger than 0, this means that the determinant of A is 0. Okay, so that's why there are infinite solutions. If the determinant of A was not 0, then the rank would equal the number of columns. So all of the columns would have had a pivot, and then matrix A would have had an inverse. And if matrix A has an inverse, then X has a unique solution, not infinite solutions like we found. So since the rank is smaller than n, therefore it means that the determinant of A is 0, and this is a singular matrix. That's why we found infinite solutions. Okay, so all this information is extra information that we get about A. But even more extra information. So the columns without a pivot turn out to be linearly dependent on the other columns. And that's true even in the original matrix. So in the row echelon form, we have these 2 columns without a pivot. But the corresponding 2 columns, the second and fourth column in the original matrix, also turn out to be linear combinations of the other 2. Okay, so using the first and the third columns, which do have pivots, we can add and subtract them in ways to produce the other columns. Okay, so if we wanted to calculate the span of these 4 vectors, of the 4 columns here, we know that the second and fourth vectors would be irrelevant in terms of the span, because they would be linear combinations of the other 2. So this again is information that the row echelon form is telling us. So you can see that the row echelon form is telling us all the secrets of this matrix A. That's why I think it's so useful to learn about Gaussian elimination, because it everything fits together nicely. So thanks for watching.